Hello and welcome to this 5-minute short. And in this one, I want to do something a little bit different. I want to show you the help feature, and I want to talk about functions. So probably stuff that people are less familiar about in Capri. But if we look at this sheet here, this is a set of sheets I've been using to talk about use of Capri, particularly in pressure relief calculations. And we've just got on the screen here a very simple sizing calculation for sizing a relief valve for vapor flow. Now, this is a spreadsheet. You can see the yellow boxes are where we type. The green boxes, magic happens and numbers appear when we put the right numbers in the yellow boxes. But what's really going on in there? And it is important as engineers that we understand the basis of our calculations. What is it actually doing? What's it trying to achieve? And indeed, you might get challenged on this by various regulators at various points. So in PEL, what we try and do is provide that information, and as much information as we can. Ultimately, this is a black box. There's code in the background, and as users, you won't be able to see that code. But we try and shine as bright a light into that black box as we can. And the way we do that is through this help up here. So I press help, and you'll see here help on the current calculation. So that will bring up, and I'll bring this over here. Bring this into here. So this is the help for this particular calculation. It tells us what it is. It's the API 520 vapor calculation. It gives us the source for this particular sheet. So where did we get these equations from? So API 520 part 1, and we've even put the sections down as well. A little bit of the assumptions. So in this particular sheet, we're assuming that the gas is behaving ideally. It's an assumption within the sizing equations for API 520. So PV to the K is constant, where K is isotopic coefficients approximated by your ideal gas ratio specific heats, which is why we should be using the ideal gas ratio specific heat for our calculations. You'll hear that in the other 5-minute shorts as you go through these, but that's the source of it. That's why. We've then got here our Capri functions. So this is what's happening within that sheet, and the way we do the calculations, we implement them as functions, just like all the other Excel functions. So sum, average, whatever it might be. VLOOKUP, another one I use quite frequently. They are there, and in a minute I'll show you why that's quite useful and what we can do with those. But it does tell you what those functions are. So if you see something you like, maybe convert value might be quite useful. In fact, let's just click on it. We can look at convert value, and it'll tell you about that convert value function as well and how to use it. We've then got the input data. So we've got those yellow boxes at the top. We also want you to put some information in there. So hopefully most of it's fairly obvious. But if you're not sure, and there's no shame in not being sure, we just want to double check, then that's what we've got there. That input data, what is it looking for? What data should we be putting in there? And if we scroll down to the bottom, I can press that little plus there, and then this gives you your calculation method. So what is it actually doing? How's the calculation working? This is the bit that shows you what we're doing. So in this case, we're checking whether we've got critical flow, whether we've got a choke or not. We've then got the sizing equation for choked flow, how it's calculating C, those sorts of good things, the units. If it's subcritical flow, then that's the equation there, etc., etc. The FT factor of subcritical flow. The purpose is not to go through this in detail, but to show you where to find it. Read those if you want to know where the source is, what the calculations are doing. All the Capri sheets have got these in the background helping you out. So I talked about these functions. So I'm going to go back to this sheet because I'm going to need to do this again for a different 5-minute short. But what I'm going to do on the 5-minute short, I'm looking at Piper. I'm looking at how to do relief device pressure drops and pressure losses around a relief device in Piper. But what I'm going to need to know, an orifice diameter, because I need to model that relief valve, that nozzle inside there. And I've got a quoted area here, and I've got a KDA specified, but I'm not going to put that into Piper. I need a certain number of millimeters. So I'm going to go over here, and what I can do is I can do insert function. So what this does, it gives me access to all of the functions that are within Capri. So all those ones that we've typed in, and you can see there are lots and lots of it. It's a little bit hard to navigate. So there's different ways of doing it. But if you see a function that you like on the sheet, then the sheet will tell you its name, which ones are there. lowers the list down. There's a search function. You can tag these, you can do favorites. What I actually want to do at this point is diameter. And yes, I know we can all calculate diameter from that area easily, but this is even easier. So I've got an area, I'm going to say that equals, I want the KDA of my valve, in this particular case, so many square millimeters. I've now got a diameter of 20.08, and I can use that in my calculation. And there's lots of these little calculations in there, Reynolds number convert, as well as the relief valve sizing, etc., etc. Have a look through. But you can use those in your own sheets. So you can build up your own Excel sheets using these Capri functions, these engineering functions, to create your own calculations. It doesn't have to just be locked to a Capri sheet, which I think is kind of neat. All right, thank you.